In this video, we will learn how to rationalize radicals. Rationalizing radicals is used to simplify fractions with a radical in the denominator. To rationalize a fraction, first we have to simplify each given radical. Then we have to determine the conjugate of the denominator. In the next slide, we will learn how to get the conjugate of the denominator. Once we have the conjugate, we have to multiply both numerator and denominator by that conjugate. Then we simplify the expression using the laws of exponents. Now, how do we get the conjugate of the denominator? If the denominator is a single radical, the conjugate is whatever we have to multiply to the given radicand in order to get a perfect square or cube. If the given denominator is a binomial, the conjugate is a binomial with the same terms but opposite operation. Now, this way of finding the conjugate of a binomial with a radical is based on the difference of two squares. Recall from the difference of two squares that if we have a binomial, if we are given a binomial a minus b, and we multiply it by a binomial a plus b, so we have the same terms but opposite operation, we get the squares of the two terms and the operation is minus. Let's rationalize some fractions with radicals, with a radical in the denominator. Let's say we are given 10 divided by the square root of 5. So in the denominator, we have the square root of 5. Okay, so first, we cannot simplify this radical further, so we can proceed to finding the conjugate. What is the conjugate of square root of 5? In this radical, we have to get a square root. Therefore, to eliminate this radical, we have to have a perfect square in the radicand. Therefore, we have to make this 5 a 25. So the conjugate is the square root of 5. Next, we multiply both numerators and denominator by the square root of 5. So let's multiply the numerators. 10 times the square root of 5. And the denominator's square root of 5 times the square root of 5 is the square root of 5 squared. Let's copy the numerator. The square root of 5 squared, of course, is 5. Okay, simplify the numbers. 10 divided by 5 is 2 times the square root of 5. What if we are given 8 divided by the square root of 12? First, we have to simplify this radical expression. So we copy the numerator 8 divided by, we know that 12 is 4 times 3. And we know that 4 is 2 squared. So the denominator becomes the square root of 2 squared times 3. Let's evaluate the square root of 2 squared. That, of course, is 2 times the square root of 3. So how do we rationalize this fraction with a radical in the denominator? We have to get the conjugate of the square root of 3. To eliminate this radical, we have to have a perfect square in the radicand. So we have to multiply this 3 by another 3. Therefore, the conjugate is the square root of 3. And we multiply that conjugate to both the numerator and denominator of the fraction. Let's multiply the numerators. 8 times the square root of 3 and 2 times square root of 3 times the square root of 3 is 3. Let's simplify the numbers. 8 divided by 2 is 4. In the numerator, you have times the square root of 3. And in the denominator, you still have 3. Next, we have 2 divided by the square root of 3 plus 3. So in this fraction, the denominator is a binomial with a radical. So what is the conjugate of that? The conjugate is another binomial with the same terms, square root of 3 and 3. but the operation should be minus. That is the opposite operation. So the square root is square root of 3 minus 3. And then we have to multiply that conjugate to both numerator and denominator. Okay, so let's multiply the numerators. Let's distribute, so that is 2 times the binomial, square root of 3 minus 3. In the denominator, we know that the product of these two binomials is square root of 3 plus 3, and square root of 3 minus 3 is the square of each term, and then you have a difference. So the square of square root of 3 is 3, and the square of 3 is 9, and again the operation should be minus. Let's simplify the numbers. So copy the numerator. 3 minus 9 is negative 6. If we divide 2 by negative 6, we get negative 2 is cancelled, so we copy the square root of 3 minus 3, and the 6 becomes 3. Now, to simplify this expression, we can distribute the negative sign to the two terms in the numerator. So the numerator becomes negative 3 becomes positive 3, and positive square root of 3 becomes negative or minus square root of 3 divided by the denominator 3. Next, we have 1 over 5 minus the square root of 7. So in this fraction, the denominator is also a binomial with a radical. So so first we have to get the conjugate, and that is a binomial with the same terms 5 and square root of 7, but the operation is opposite this operation, so it should be plus. So the conjugate is 5 plus the square root of 7. Now we have to multiply that conjugate to both numerator and denominator of the fraction. Let's multiply the numerator. So if we distribute 1 to the two terms in this binomial, we get the binomial 5 plus the square root of 7. And from the difference of two squares, we know that the product of these two binomials is the square of each term, and the operation is minus. So 5 squared is 25, and the square of square root of 7 is 7, and we have minus. Let's simplify the numbers. 25 minus 7 is 18, and this is the final answer. Next, we have 6 divided by the cube root of 4. If we want to simplify this fraction, we have to eliminate this radical in the denominator. Now, to eliminate this cube root, we have to have a perfect cube inside in the radicand. Okay, so we know that 4 is 2 times 2. To make it a perfect cube, we have to multiply it by another 2. Okay, therefore the conjugate of cube root of 4 is the cube root of 2. So we multiply that conjugate to both numerator and denominator of the fraction. Let's multiply the numerators. 6 times the cube root of 2. If we multiply the denominator, we have 4 times 2, that is 2 cubed. Let's evaluate the denominator. So copy the numerator. The cube root of 2 cubed, of course, is 2. Now let's simplify the number. 6 divided by 2, that is 3. Then copy the cube root of 2. Lastly, we have 12 divided by the cube root of 9. To simplify this fraction, we have to eliminate this radical in the denominator. To eliminate this cube root, we have to have a perfect cube inside the radical sign or radical symbol. Okay, we know that 9 is 3 times 3. To make it a perfect cube, we have to multiply it by another 3. Therefore, the conjugate of cube root of 9 is the cube root of 3. We have to multiply that conjugate to both numerator and denominator of the fraction. So let's multiply the numerators. 12 times the cube root of 3. If we multiply the radicands in the denominator, we have 9 times 3, that is 3 cubed. So if we evaluate this radical in the denominator, that is 3. Copy the numerator. Now we can simplify the numbers. 12 divided by 3 is 4, and copy the cube root of 3. If you have any question, please leave a comment.